projectile motion for complementary angles. We'll start with first this particular topic. So I'm going to choose now here. I'll choose two particles. There's a particle 1 and particle 2. Particle 1 I'll project. It will move in a red color path. This I shown. And it will have a range r. Then what is the angle of projection of the particle 1? Let it be 90 minus theta. Then the angle of projection of particle 2, let it be theta. This theta, 90 minus theta, they'll become complementary angles. The particle 2, now the particle 2 will move in this particular parabolic path. Both will move in parabolic path. So we are going to compare the overall, what about the range, time of flight, and what about the height ascended for the complementary angles. So first I'll start with the H1. Time of flight will calculate. T1 equal to 2u sine theta 1 by j. How theta 1 and theta 2 are related? First we should have the basic equation. I think theta 1, if theta 1 is equal to theta, what about theta 2? Theta 2 will be 90 minus theta. We'll have this one. So this will be 2u sine theta by j. What about the time of flight? 2u sine theta 2 by j. This should be equal to 2u sine of 90 minus theta by j. Sine of 90 minus theta will be, so sine of 90 minus theta will be cos theta. So the time of flight of this will be 2u cos theta by. They'll have different time. They'll have different time. We'll compare the maximum height ascended. H1 equal to u square sine square theta 1 by 2g, which is u square sine square theta by 2g. H2 equal to u square sine square theta 2 by 2g, which is u square sine square 90 minus theta by 2g, which is equal to again cos square theta by 2g. So what do we expect now? Time of flight, they'll be different. We'll go for range. Range equal to u, both are projected the same speed. Look at this one. Both are projected same speed. So therefore now this will be u1 cos theta 1 into t, which is u cos theta t1 will be 2u sine theta by g. What about the range due to the second projectile cos theta to theta 2? So this will be u cos of 90 minus theta. This will be 2u cos theta by g. This will be u sine theta 2u cos theta by g. Finally, we'll end up with, so therefore what we can compare, R1 equal to R2. What about the time of flight? T1 not equal to T2. What about the H1? H1 not equal to H2. I think that's what I'm indicating in the diagram. Check it. In the diagram, we have things very clearly here. What about this range? This side, H2 and H1, they are different. Ranges are equal. But what about time taken? The time taken of this and this will be different. These things is what we are concluding. So for complementary angles, what is the basic condition? The range will be equal. The range will be equal. And what about the height and time of flight? They will be different. Okay, we'll have one example itself. No? Here I brought it. So we have the, clearly you can see this. this particular thing for 15 degrees, the range for you can see that the range for 15 degrees will be equal to that of 75 degrees. And similarly, the range for 30 degrees will become equal to that of 60 degrees because these angles are complementary angles. The range will be equal. And for which way and for what it will be maximum range? The maximum range will be, we will calculate here. R equal to u square sine 2 theta by g. For theta 45 degrees, so 2 into 45 will be sine 90 degree. Therefore, the maximum range will be u square by g. So, what is the maximum range? U square by g. What about these ranges? They will be different. And the maximum range will be for 45 degrees. Okay, I think almost all things with example I'm giving, you need not to bother much anything. So these are basic idea. The time of flights will be different. Then T15 degrees will be less than T75. Time of flight has to be different. Let me write like this. Then definitely H75 degree. Maximum height ascended when it is projected with an angle 75 degree here. Definitely that maximum height ascended will be more. Similarly, we'll go for T time of flight for 60 degree will be greater than that of 30 degrees. Then maximum height ascended for 60 degree will be greater than that of 30 degree. I think these things I am showing it here. You can check it here. I'll show for H75 and this will be you have comparison here only, you can compare things like this. There's a one for complementary angles, the range will be same and the time of flight and the maximum height will be different here. There's one basic idea. Okay, we'll go for the next topic. The same projectile motion. Next one more we have that. So again, once again, this person will kick the ball and it will impart a velocity u, and because of the weight and the velocity, it will move in a parabolic path. When it is moving in parabolic path, this ball, at one instant you can see it is at same height, no? At two different instants of time. Means at t equals 0, I'll kick the ball. Let's have this weight mg. It'll be easy for you. At two different instants of time, the projectile will be at same height. Let me choose this one. You can see this one. It will be at same height at t equals 0. At time t1, here it will have velocity up. And it will have the same speed here. It will not, velocity will be different, but the speed has to be same. And Let's go for other things.